Alright, Chapter 3 Study Guide, Limits, Problem 2b. Another piecewise continuity problem where we need to find values, this time k and j, that are going to make this function continuous for all values of x. So same as last time, except a little more complicated because now we're going to have to come up with two equations and create a system to solve them. So let's go ahead and jump right in. So like I said, the process is the same, except now we're going to be looking at two different x values. Where does our function need to be at x equals -1, and where does our function need to be at x equals 2? So let's go ahead and look at the first one to start. Now, we need to note that this middle one, because I have that inequality there, x is greater than or equal to -1, when x is greater than or equal to -1, our function is going to equal that. So, we need to substitute -1 in for x, so we get 3j plus -1 equals, and now we want it to be continuous at -1, so we need to figure out what the limit of this function needs to be. So basically, where does it need to go? Well, it needs to go there, so let's set it equal to that. 2 and x, remember, we're substituting -1 in for x, so we get -1 squared plus k. Okay, cool. I'm going to stop there for the moment. Now I'm going to look at my second set of equations. So now I'm looking where x is 2. So again, I'm going to need to use this function again. And let's go ahead and make myself a little divider here. Okay, so now we'll do the same thing. So we get 3j plus x. This time x is 2, so 3j plus 2 equals 4k. X is 2, remember, so substitute that in, plus 19. Now let's simplify this a little bit, and now I'm going to jump back to my blue equation, and I can see that I have 3j on the left of each of these, so I'm going to solve both of these equations for 3j, because that's going to be my simplest move. So first off, if I think of -1 squared is 1 times 2 is 2, and then I have this -1 here, so I want to add 1 to get rid of that, to get 3j by itself. So I'll add 1 to both sides. 3j equals 2 plus 1 is 3 plus k. Now if I go look at my orange equations, same thing. I want to solve for 3j, so I get 3j by itself by subtracting 2. And 2 times 4 there is going to give me 8k plus 19 minus 2 plus 17. So now basically what I've done is I have two equations here, both equal to 3j, so I can use substitution and set them equal to each other. So I get 3 plus k equals 8k plus 17. Well, that's sweet because now I have an equation with only one variable in it, k. So I'm just going to solve for k. So I'm going to subtract k from both sides. And I'm also going to simultaneously subtract 17 from both sides. That's a 1. And I'm going to get 3 minus 17 is -14 equal to 8k minus k is 7k. A little fancy arithmetic will allow me to get k equals -2. Cool. Not quite done though, because now I have to go back through and I have to figure out what j is. So again, I'm going to need to use one of my two equations here to figure out what j is going to be. So it kind of stinks, I have to scroll. But my first equation, I can substitute that k value of -2 in for it. So I'll get 2x squared, and I have to peek again. 2x squared minus 2 equals 3j plus x, and we want to check that out at the x value of -1, so I substitute in, and I get 2 -1 squared minus 2 equals 3j minus 1. So I can simplify, and I'll get 2 minus 2 is 0. Well, that's okay. 2 times -1 squared. -1 squared is 1, times 2 is 2. 2 minus 2 is 0, equals 3j minus 1. So 1 equals 3j. So j equals 1/3. So I got j equals 1/3, k equals -2. And now I'm done.